Okay, so in this problem, we have this information about a function, and we're trying to sketch its graph. So let me just draw an axis here. And so basically what we're going to do is just sort of go one by one here and take each one of these characteristics and use them to get a rough picture. Now, I'm going to draw one graph, but there's many others that would also work as long as they satisfy all these conditions. So here, let's start off with the first one. The first one says that f of x is equal to 0 at x equals -5, 0, and 5. So if, for example, this is -5 and this is +5, then what this is saying is that my function has to hit right here, and right here. So the function has to equal 0 at each of these points. Okay. Now, here it says that the limit as x approaches -infinity, so over here in this direction, over here this is -infinity, as x goes in this direction, the function should go towards infinity. So if x is going this way, my function has to be going up to infinity. Okay. Now the next one, the next condition says, okay, the limit as x approaches +infinity, so over here on this side, +infinity, should equal to -3. In other words, if, -3, let's just say this is -3, my function should be approaching -3. So I don't know where it's coming from, but this is basically saying that on this direction, on this side, the right side, I have a horizontal asymptote there. So I'm just going to draw the asymptote, and once I know more information, then I'll know whether it's coming from down here or up here. Okay, and then this last condition says, okay, f prime of x is equal to 0 at x equals -3, 2.5, and 7. So at each of these points, my function should be flat, right? Because the derivative equals to 0 means that you have either a high spot, a low spot, maybe that one's not very good, flat spot, like that. So here, let's so here I should have a flat spot, so right here at -3, so let's say -3 is right here, and at x equals to 7, let's say 7 is right there. So at each one of these little arrows, it should be flat. So I think that's enough to draw the picture. We'll come, this way it's coming down. Now it has to hit here, and then it has to be flat at -3, so let's just do that. But I know that it has to go back here, so let's just go back right here, and then I know that it's flat here, so that means that it has to also have a flat spot. So but now, well, should it come down, or, well, I know that since there's nothing between here and 5, well, I could either come down and then come back up, or you could have also gone up and then down. So maybe I'll draw a couple of different variations that still satisfy all these, so just to give you an idea of what the variations are. But I know that it's going to hit right here, and then it has another flat spot right here, but then I know that it has to go towards -3 as you go to infinity, so it has to come back down and then follow this point right here. So now, just to kind of give you another idea of what else could have happened, you could have also had a function that comes down here, and then maybe it doesn't specify that it has to be flat here, but it doesn't say that it can't be. So you can just make it touch there, be flat here, and then come down here, and then come back up, and then come here, and then let's say it comes back up, flat, and then comes, and then goes that way. And that's also allowed. So, there are lots of different variations that you could get. Okay, so here we have quite an interesting problem. We have two functions. G of x is square root of x, and f of x is kx squared, where k is a constant. So it doesn't specify what k is. Okay, so the first one says find the slope of the tangent line to the graph of g at the point 4, 2. So, okay, so to find the slope, well, the first thing I need to do is find the derivative, of course. So the derivative, of g, not f prime. What am I doing? Okay, g prime of x is equal to, so the derivative of square root of x is 1 over 2 square root of x. And so then the slope is equal to plugging in the point, the x value, in this case 4, into this guy. So 1 over 2 square root of 4, this gives me 1/4. Okay, so this is the slope. Okay, now if I want to find the equation, well, next thing I need to do is find the y-intercept. So I've got y equals to mx plus b. And so I'll plug in what I know. I know that my slope is 1/4. And I know that my x value is 4. And I know the y value is 2. Okay, so that's great. So this means that b is going to equal to 1 when I solve for it, right? Because 4 times 1/4, that's 1. You move it over, and so you get b is equal to 1. So then my tangent line, my equation, is y equals to 1/4 x plus 1, mx plus b. Okay, so that's the equation of the tangent line. Okay, now for C, it says that if the graph of f contains the point 4, 2, find k. So what this is saying is, so f of x is kx squared. Now what it's saying is that it contains the point 4, 2. So if you plug in 4 for x, y is equal to 2, or in other words, f of 4 is equal to 2. So, with this information, well, you can solve for k, because then 2 is equal to k times 4 squared, which is 16. So then k is simply equal to 1 over 8. Okay, let me break this up here. Okay, so I've found k. So then why don't I might as well, let me just write down now, k is constant. So f of x is equal to 1/8 x squared. Okay. So then it says, okay, where does the graph of f intersect the tangent line found in part B? So in other words, it's asking, where does this function f equal to this line 1/4 x plus 1? So, what we're doing is we're solving the equation. We're saying, let me move this over a little bit. When does 1/8 x squared equal to 1/4 x plus 1? So to solve this guy, well, the easiest thing to do first is let's just get rid of the fractions, everything. So let's just multiply everything, both sides, by 8. So that would give me x squared equals to 2x plus 8 when you distribute everything through. And since this is a quadratic equation, let's move the 2x to the left and the 8 to the left. Okay. And then we can factor this guy. X and x, and then two numbers that multiply to -8 and add up to -2. That would be -4 and positive 2. And so then from this I get x equals to 4 and x equals to -2. So there's two spots where they intersect. And so, I mean, that makes sense, right? Because 1/8 x squared is a parabola and 1/4 x plus 1 is a line. So you would expect, to have a parabola and a line. If they hit, they're probably going to intersect twice. But those are the x values where they intersect.